Okay, hello Farouk. So for your punya chapter 3 for your objective paper, for question 1 and to question 3, I'll just give you the answer B, B and C. Okay, so this is more on two facts lah. So there's not much understanding. You just need to understand if exothermic, what is the value of your punya delta H, and what should you expect. Yeah, and what should you expect when the value of delta H is negative, which is temperature of mixture increases, and what are the types of endothermic reaction, exothermic, so you can look at your textbook lah. So you can look at here, you can look at the examples and so on. So what I want to go through is your question 4 and question 5, but in this video I'll just explain question 4 first. So this is your question 4. So in an experiment you have 25 centimeter cube of this molarity of lead 2 nitrate solution is added to the same thing, but the element is different, the compound is different. So we have the initial temperature, which is 29 Celsius, and the heat of precipitation, which is the delta H, is negative 50.4 kilojoules per mole. So we need to find the maximum temperature. So from this statement, I automatically know I need to use the Q equals to MC theta, because from QMC theta we're able to find the final temperature, which is represented by T subscript F lah, in this case. So the answer would be D then. So I will explain to you step by step. So first step is you write the element for the two compounds. You write the chemical formula for the two compounds. So for lead 2 nitrate, it would be Pb and O32. Okay, so just remember lah. If you don't remember, just remember Pb charge is 2 plus, and O3 charge is negative 1. Therefore, if you combine them together, you do trading of charges. And then this must be bracket showing that the 2 is referring to both of this. Okay, so the same thing with K2SO4. K2SO4, you have K plus and SO4 2 minus. So if you combine them, you do trading of charges. So the 2 will travel to K here. Okay, so now then you need to know sulfate. Wait, I don't want to wrongly explain this. You will produce potassium with potassium sulfate solution, and then okay, so you will produce a type of salt, I think. Yeah, it's a type of salt. So this type of salt, for lead salt, lead salt, it is not soluble. For this one is on your chapter 6 form 4. So you can look at the properties again. So for lead, for sulfate salts, all soluble except for lead, and couple more things lah, if I recalled correctly. So you can verify it on your textbook and tell me now whether I'm correct or not. Your reference books, right? So next then you construct the equation. So you need to find the precipitate form, because this one is a precipitate reaction, so heat of precipitation. So the heat that is produced from precipitation lah. How do I know? It's because it is mentioned on the sentence here. And then automatically try to plant it in your mind. PbSO4 is most probably formed lah, which is a solid, which is a type of precipitate lah, because it's solid. So now then, how do we create PbSO4? Is you take Pb from this PbNO3 and then you take SO4 from this K2SO4, then you combine them together, so you have this lah. So then okay, continue. Next you will have to do stoichiometric relationship. So first you do base from this equation first. So you can see that PbSO4 are all 1 mole. So you know that 1 mole of Pb reacts with 1 mole of SO4 minus, produce 1 mole of PbSO4. Okay, which is solid lah. This is bracket solid. Therefore, what I'm doing here is I'm trying to find the mole of Pb2 plus based on the equation given, because we know that the number of ions for Pb2 plus is the same as the number of moles for this element itself. So we can is equals to PbSO4. Wait, wrong. Pb, where's the element PbNO3? Okay, so it is equal. So you need to write this down also, so that the examiner know lah that you're comparing the same thing. So next is you're trying to find the mole. So if you're trying to find the mole of Pb2 plus, you use mv, n equals to mv. But remember, if your volume is in cm cube, you need to divide with 1000, because in chemistry we always use the m cube. Okay, so for this one I use 25 times 1 divided by 1000, because the volume of PbNO3 is 25 cm cube, the 2-nitrate solution. Okay, 25 cm cube. So and then I times with 1, because the molarity is 1 mole per dm cube. And then I'll have the answer, and then I'll do stoichiometric relationship lah. 0.025 mole of Pb2 plus reacts with 0.025 mole of SO4 minus. This one also same value, because as you can see here also same value. Okay, so we'll produce 0.025 mole of PbSO4. Why do I know it's 0.025? Because you can see that here also 1 mole, so therefore it should be the same lah. So next is what you're going to do is you're going to use the equation Q equals to mc theta. So theta is change of temperature. So we already have the total mass. So remember 1 cm cube is equals to 1 gram. Okay, so therefore in the solution total we have 50 cm cube, so we have 50 grams. Okay, and then for the constant is 4.2, and the change of temperature, the initial temperature is 29, we're trying to find the final temperature, so we let x equals to final temperature. So you need to write this down lah. Okay, so remember the two things that you need to write down is first mole of Pb. So I need you to do the correction of PbNO3, and second one is the this, let x equals to final temp. So I want you to do this on your correction. Okay, so now then how do we get the value of Q? Because first you know that delta H is negative 50.4 as given in this question here. So how do we get this value of Q? Is we get it from doing stoichiometric relationship. Stoichiometric relationship is basically the based on equation blah 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 of the precipitate form, the mole of the precipitate that is formed, and the heat change. So we know that 1 mole of PbSO4 will release 50.4 kilojoules per mole of heat. So then 0.025 will release Q. Q is heat release lah. 50.4 is the heat change. So and remember, for calculation, you don't write the negative final answer, but you write the negative, okay, to show that it's exothermic lah. So for this one then, Q is equal to 0.025 times with 50.4, okay, 0.025 times with 50.4 divide with this value here, and then you have 1.26 kilojoule. But remember, first change into joule first, and then you have the value of Q that you will use later. Then you will substitute the Q value into the earlier equation, which is here. So we know that the value of Q is 1260, and then you just do algebra, and then you will have the value of X, letting the examiner know X is final temperature, and then your final answer, you say that 35 Celsius is the final temperature, and then you just write, circle the answer here lah. Okay, so don't worry, usually objective questions are not like really high difficulty like this, but if it is, you need to manage your time wisely lah. Okay, so the next video would be on question 5.